on this computer. I am going to share my screen so that we can all be looking at the same thing. And I'm going to ask each of the group to sort of present what they found, right? So starting with room number 1, whoever you are, you got the floor.
So for our problem, it was like similar to that problem before, but kind of in reverse of what we did, because instead of the kilograms, we had the tension, which was 125 newtons. So first we knew, because this is like the same as the problem before, that it had constant velocity because the ball wasn't moving. And then because we knew that, then we knew that it would be balanced and have a net force of 0. And so then you can see on the right, here's our force diagram. And we have 2 congruent arrows, one going up and one going down. And the one going up is tension force on the cable on the ball. And the one going down is the grav force, which is the Earth's gravitational field on the sphere. So then again, this just showed what we said in part B, which is the net force is 0. So then to find the mass of the ball, we basically did the reverse of what we did for problem 1. So in this case, we knew that the tension was 125 newtons and that the Earth's gravitational field strength is 9.81 newtons per kilogram. So what we did was we did 125 newtons divided by 9.81 newtons per kilogram, and then got 12.742 kilograms for the mass of the ball, which we rounded to 12.7 kilograms.
Cool. Thank you, room 1. The rest of the class, any thoughts about their answer? Anything that's a good answer? Anything that could propel that answer from the realm of good to the realm of awesome? Which is, our goal in life is to be awesome. Anybody? No? No, it's good. I would have liked to see, it's interesting, Leila, at some point you were like, I wonder what we did. Oh yes, we did force of tension divided by GFS. It would have been nice to have that written somewhere, like what relationship you were gonna use, right? And I just want to make sure that you people are not starting to think about the fact that it's the force of tension divided by the GFS that was the mass, because that's not the case, right? It's the force of gravity divided by the mass that's equal to the GFS equal to mass. And it turns out that the force of gravity is also equal to the force of tension. Right? Let's see. This was room 1. Room 3, you had the same problem. Anything you want to add? Room 3, that's Mark, Reed, and Zach.
I don't know. We did a no, but we didn't do the other
ones
two.
Or
yeah. But the no, we just put like all the facts. We wrote the diagram. We said it was balanced. Net force is 0. And then the equation down there helps us get the. Oh, I forgot.
Nice catch. Nice catch. Are we going to change it? Good eye, young Padawan. Nice job. Yeah, good. And again, like the no-want relationship algebra thing, like that's only a scaffolding for you to use if it's helpful. If you can solve the problem without, fair play, right? You can certainly do that. Room 2, you had a slightly different problem. Who wants to talk to us about room 2? That's Elliot.
I can talk about it.
Any one of you 3, like it's.
Oh, okay. Oh, yeah, I'll go. So we thought that the block had constant velocity. It's not moving, and this also means that the forces will be balanced. which then also means that the net force is 0 because nothing's happening. There are two forces acting on the block, normal and gravitational force. Normal, meaning the table on the block, and then gravity, the gravitational force on the block. For mass, we decided to go with the equation of 3.55 divided by 9.81 to get mass instead of newtons, of course. And so we got 0.36 kilograms. That's pretty much it for what it was.
Okay. Again, thoughts from the class. How do we make this from like a really good answer to an awesome answer? It's one thing that they could have added in there that would have been probably helpful. Yeah, Leila?
Maybe if they wrote like the relationship or the equation they
That's exactly the same thing, right? Fine answer, you got the right thing, you have the right numbers, like it's looking really great. Like I love your force diagram, everything is good. If you could just give me the relationship so that I'm, that would be really awesome. Let's see, room 4, you had the same problem. Anything you want to add? No? Room 5, you had the same problem. Anything you want to add?
There's nothing really I'd add. We didn't really get to finish the problem, so we were just setting it up right now.
Got it. Next time, if you guys are not close to finishing the problem and the time is running out, can you send me an email? Because I can give you more time. I just had no idea, right? Cool, excellent. So thank you. I'll stop sharing.